All right, so we're going to learn how to solve systems of equations in two variables using the reduced row echelon form. At the end of this lesson, here's what you're going to know. You're going to know what a reduced row echelon form of a 2 by 2 matrix is. You're going to also know the steps that you need to follow to solve a system of equations in two variables in reduced row echelon form, and you'll also know exactly how to apply those steps to some actual examples. So let's go ahead and get started. What is a reduced row echelon form of a 2 by 2 matrix? First of all, we need to realize that a matrix is in reduced row echelon form if it satisfies the following conditions. So what we're going to do here is we're going to draw a matrix here. We're going to draw a matrix here, and I'm going to put this right here to represent the constant values. So this is going to be, let's call it A here, and let's call it B over here. And we're saying here the first number on the first row is 1. The second number on the second row is 1 right here. And every other number is a 0. So this is what we're looking for. A and B just represent any kind of constant. It doesn't matter what it is. We're fine with that. We just have to make sure that on the left side of this vertical line, this is what the matrix looks like. So how do we go ahead to solve a system of equations in two variables using the reduced row echelon form? First of all, you want to express the system as an augmented matrix, and then you're going to write the desired matrix in reduced row echelon form using the elimination method of solving systems. That's exactly how you're going to go ahead to create this matrix in reduced row echelon form, and from that you will get the solution to your system. So let's go ahead and get started with some examples. So the first thing, so we have solved the system of equations below using the reduced row echelon form. So we have 5x plus 3y equal to 41, 2x plus 3y equal to 20. So the first thing we're going to do is to create an augmented matrix. So what our augmented matrix looks like is we take 5 here, we take 3, and then we take 2 here, we take 3, and then we have our vertical line, and then we have 41 here, and then we have 20 here. So this is our augmented matrix, and we need to remember what we're going for. We're going for 1, 1, 0, 0. So what I'm going to do here, the first thing I'm going to do is to go ahead and simplify this one right here, the second row. So we're going to do a few things here. I'm going to say row 1 multiplied by 5. Sorry, row 1. I'm going to multiply row 1 by 2. And I'm going to multiply row 2 by 3. Actually, let's go ahead and multiply row 1 by 2 and row 2 by 5. Okay, so let's go. Row 1 multiplied by 2 and row 2 multiplied by 5. So let's go ahead and get that going. So we have 10, 6, and then we have 82. And then here we have 10, we have 15, and then we have 100. So this is what our matrix is going to look like. And then I am going to change. Remember that the first thing we need to do is to make this bottom the first element or the first member of the second row. So let's say the first column of the second row, we need to change that to a 0. So what we're going to do here is we're going to say row 2 is equal to row 1 minus row 2. So let's go ahead and get this going. So we have 10 here, we have 6, and then we're saying row 2 is now going to be row 1 minus row 2. So 10 minus 10, that is 0. 6 minus 15, we have negative 9. Don't forget, we're going to leave this as 82. And here we have 82 minus 100, negative 18. Okay, so that's that. So let's go ahead and then we'll say row 2 divided by negative 9, or row 2 multiplied by negative 1 over 9. So what we're going to have here is 10, 6, and we have 82. And then here we have 0, 1, and then we have 2. So the next thing we're going to have to deal with is these 6 right here. And I'm using a different color. We're going to have to deal with this right here. So what do we do to get rid of that? So what we're going to see here is we're going to say row 1 is equal to row 1 minus 6 row 2. So I'm going to just write what 6 row 2 is going to look like right here. It's going to be 0, 6, 12. So what we have here is row 1 minus 6 row 2. So 10 minus 0, we have 10. 6 minus 6, we have 0. 82 minus 12, we have 70. And then row 2 is 0, 1, 2. So now we're going to go ahead and say row 1 is equal to row 1 multiplied by 1 over 10, or row 1 divided by 10. So that is going to give us 1, 0, and then we have 7, and then 0, 1, and then we have 2. So what this simply means is that this is going to be our x variable, this is our y variable. So x equal to 7, y equal to 2. So we can write this as 7, 2. So let's just do a quick check to make sure that we did it the right way. So 5x plus 3y, 5x plus 3y. This is going to be 35 plus 6, 41. Let's go again. 2x plus 3y. This is going to give us 20. So this is a way to check that we have done this the right way. Let's go to the next set of questions. I'm always going to do this right here. 1, 1, 0, 0. That's what we're looking for. So let's go ahead and write this in reduced. So we write this in augmented form. So this is going to be 2, 4, 3, negative 1. And then we are going to have 26 here and then 4 over here. So what I'm going to go after is I'm going to go after this 3 over here. That's what I'm going after. So what I'm going to do to get to a point where we can deal with that is I'm going to multiply row 1 by 3 and row 2 by 2. The goal is to make sure that we have the same number here, or the same integer here. And so the easiest way to do it is to find the least common denominator of 2 and 3 is 6, and figure out what you need to do to each of these to make them 6. So row 1 multiplied by 3, we're going to have 6, 12, and then we have 78. Row 2 multiplied by 2, we're going to have 6, negative 2, and then 8. So now what we're going to do here is we're going to say row 2, because we need to get this 6 here, make it 0. So we're going to say row 2 equal to row 2, or you can say row 1 minus row 2. We can actually do that. That's a lot better. So we say row 1 minus row 2. Row 2 is equal to row 1 minus row 2. So we're going to keep row 1 the same as what we have here. So we have 6, 12, and then 78. And then we have 6 minus 6 is 0. 12 minus negative 2 is 14. and 78 minus 8 is 70. So we go row 2 divided by 14, or we can say multiply by 1 over 14. So we keep row 1 the same, 6, 12, and then 78. And then we have 0, we have 1, and then we have 5. So the next thing we're going to do is to find a way to get rid of this 12. So what we're going to simply do here is we're going to say row 1 is equal to row 1 minus 12 row 2. So let's go ahead and figure out what 12 row 2 is going to be. We have 0, 12, 60. So that is going to give us, we leave row 1 exactly the way it is. Actually, we leave row 2 the way it is. So that is 0, 1, 5. And then row 1, we have 6 minus 0, we have 6. 12 minus 12, we have 0. And then 78 minus 60, we have 18. So now we're going to say row 1 divided by 6. So that is going to give us 1, 0, and then we have 3. And then here we have 0, 1, 5. So remember, this is our x and this is our y. So x is equal to 3, y equal to 5. So we can say this is simply the point 3, 5 as the point of intersection. So let's go ahead and check if our answers are correct. It's just a habit that is going to develop. Just verify your answers. So 2x plus 4y, this is equal to 6 plus 20, 26. And then we have 3x minus y. So this is 9 minus 5, we have 4. So we can see that this validates, or this verifies that 3, 5, x equal to 3, y equal to 5 is the correct solution of this system. So let's do one more. As usual, I'm going to just put this on the side, 1, 1, 0, 0, okay? And then we have 3x plus 2y equal to 16, 2x minus 3y equal to 2. So I'm going to write this in augmented form first. So we have 3, 2, 16, 2, negative 3, and 2. So here again, we're going to multiply this by 2, multiply this by 3. So I'm going to say row 1 multiplied by 2, row 2 multiplied by 3. And so let's see what that's going to give us. We have 6, 4, 32. And then row 2 multiplied by 3, we have 6, negative 9, and then we have 6 over here. So now what we're going to do here, because we're trying to change this to a 0, so we're going to say row 2 equal to row 1 minus row 2. So let's go ahead and simplify that. So we have row 1 doesn't change. We have 6, 4, and then we have 32. And then let's go ahead and do a subtraction. 6 minus 6, we have 0. 4 minus negative 9, we have 4 plus 9, which is 13. 32 minus 6, we have 26. So now we go row 2 divided by 13. So we're going to leave row 1 the way it is, which is 6, 4, and then we have 32, 0, 1, and then we have 2. So the next thing we're going to do here is we're going to simply say row 1 equal to row 1 minus 4 row 2. So let's go ahead and create our 4 row 2, 0, 4, 8. So that is going to be, we're going to leave row 2 exactly the way it is, 0, 1, and then we have 2 here. And then we go 6 minus 0, which is 6. 4 minus 4, we have 0. 32 minus 8, we have 24. Then we go row 1 divided by 6. So that is going to give us 1, 0, and then we have 4, 0, 1, 2. And remember, this is our x coordinate, this is our y coordinate. So we simply have x equal to 4, y equal to 2. So we have 4, 2 as the point of intersection. And let's verify our answers. So this is 3x plus 2y, 12 plus 4, 16. And then we have 2x minus 3y. Sorry, that is going to be 3y. So this is going to be 8 minus 6, which is 2. So this simply verifies that the solution to the system is the point 4, 2, where x equal to 4 and y equal to 2. So generally, these are the steps you want to follow when you want to solve a system of linear equations in two variables using the reduced row echelon form.